You've probably heard of DirectX API or Twitter or Facebook API, but do you know what API actually means? Hello everyone and welcome to yet another episode of Darko's Game Dev Cookbook. In today's episode I'll be demystifying APIs, the glue of the software world. Let's go! First things first, let's break the API acronym down. API stands for Application Programming Interface. Interface, according to the dictionary, is a point where two systems, subjects, organization, etc. meet and interact. For example, a steering wheel is an interface to your car. It's a boundary between you and the car, enabling you to steer the car left or right. This interface is a boundary between two physical systems, as both you and the car are real physical objects. Let's call this a physical interface. The second kind of interface is where one side is virtual and the other one is physical. A good example of this would be the graphical user interface on the car's touchscreen, for example. Tapping on different elements on the screen enables you to interact with the car system to your liking. You are the physical component and the software on the touchscreen is virtual. Let's call this type of interface a physical virtual interface. Thinking of these two types of interfaces, they both involve at least one physical component. First you had the steering wheel, which was an interface between you and your car steering system, and then you had the graphical user interface on your touchscreen in the car, which was the interface between you and the car's software system. Now we're ready to reach the universe of APIs. To do this, we need to go one step deeper into the matrix, the place where everything is virtual and the only living entity is software. In this world, there are no physical components. You probably see where this is going now, so let's just lay the definition out. APIs are interfaces between two pieces of software. But software talks in zeros and ones, so why does it need interfaces to communicate? Well, in theory, you could make two pieces of software communicate without an interface by implementing some custom logic that would handle communication in both systems. But if you do so, it would be really hard to introduce more systems to talk to them, as there is no clear language that the new software should speak just to join the conversation. This is not scalable or maintainable approach. So how do you make this better? The better approach would be to standardize the communication so that the systems involved have some sort of a contract they could agree on. That's where APIs come into play. If an application wants to be able to accept communication in a standardized way, it needs to define its application programming interface, its API. Whoever wants to communicate with this software needs to interact with it through the API. In a practical sense, this could, for example, be a set of functions or network endpoints. Let's look into a real-world example. You just started work on your own game and you need to figure out how to render it. You think about it for a bit and realize, well, I will need to have my game talk to the program that controls the graphics card, also known as the driver. How do you do that? Well, here you have two independent pieces of software that need to talk to each other. You have your game and you have the graphics card driver, which means that you need to make your program talk to the driver using some sort of an API, right? You search online and find this cool graphics API called OpenGL. This API should enable you to easily render something on your screen using a set of commands. Perfect. So now you know a way how to talk to your graphics card driver. Just as ordering from a restaurant menu, you can now list your orders as a set of OpenGL function calls in your code to get the desired result. So API is something an application or any piece of software exposes to others that makes it possible for any other part of the software to communicate with it. APIs can be internal or external. Internal API enables modules within the same system to communicate with each other concisely. This kind of API is what's usually established when you have big systems that have many semi-watt independent pieces of code. It's often used in big corporations because keeping a contract in a form of an API is crucial to develop different modules of code separately while still making sure that their interaction keeps working as they change. External APIs, on the other hand, are APIs used for communication between different systems. For example, Facebook or Steam API enables your application to interact with them as a completely separate system. When talking about API complexity, some APIs provide only a basic set of functionality, and some others are quite extensive and enable you to affect the software you're communicating with greatly. It all comes down to how the API is designed. If we go back to the vehicle example, your steering wheel enables you to move left or right. You also have the gas and brake pedals to make the car go slower or faster. If we think of this system as a virtual system, the API for controlling your car would have the hooks that would enable you to move the steering wheel left or right and push the gas and brake pedals less or more. These hooks would be a part of the API definition. It's a contract signed by you and the car, which results in a set of official things things you can do to make your car move where you want it to move. Regarding API complexity, this sort of API would be quite basic, but to demonstrate how different API designs could be, you can imagine in this car example that you might have a way to control, I don't know, the exhaust of the car or affect how much oil is injected into the system. That would be a whole new layer of depth and complexity, and you will, as you explore different APIs, definitely stumble upon APIs with vastly different complexities and depth. And that would be all for today's video. Now you know what API is. If you enjoyed today's video, make sure to hit that like button. If you like the content I'm creating in general, make sure to subscribe as well. Till the next time, enjoy!